Okay, so we're looking at homework from section 3.3. This is question number 9. Let's go ahead and read the question. The table below shows the results of a survey that asked 1,068 adults from a certain country if they favored or opposed a tax to fund education. A person is selected at random. Complete parts A through C. So part A asks find the probability that the person opposed the tax or is female. Part B, find the probability that the person supports the tax or is male. And then part C, find the probability that the person is not unsure or is female. So let's look at the addition rule. We have these statements. The probability that event A or event B occurs is probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. And then if they're mutually exclusive, the probability of A or B becomes probability of A plus the probability of B, because the probability of A and B when they're mutually exclusive is 0. So in part A, are these two mutually exclusive? Is it possible to oppose the tax and be female at the same time? When we look at our table, the ones who oppose the tax and are female, there's 297 of those individuals. So since there are people in that category that overlaps, these are not mutually exclusive. So we have to do the original version of the addition rule that has the subtraction of probability of A and B at the end. So for us, this would be the probability that somebody opposes the tax plus the probability that they are female minus the probability that they oppose the tax and are female. We're going to eliminate things from the table that we don't need to look at. Probability that they oppose the tax, well, that's going to be the bottom number of that column for oppose divided by the total 1068. So it's 620 over 1068 plus the probability that they're female. So we'll look at the row with females. There are 563 females in this survey. So 563 over 1068. And then we have to subtract away where the row and the column overlap. So where the row for females and the column for those that oppose the tax overlap would be the 297 out of 1068. When we add and subtract, that ends up being 886 over 1068. And as a decimal, we get this nice long 0.82958800149. It asks us to round to the nearest thousandth. So this would be 0.830. Let's look at part B. In part B, we're asked the probability that the person supports the tax or is male. So again, are they mutually exclusive? Are there individuals who support the tax and are male? Yes, there are 172 of those. So this is the original version because these are not mutually exclusive events. Probability that we support tax plus the probability that somebody is male minus the probability that they support and are male. So let's go ahead and get rid of the stuff we don't need to look at. It's not gone, it's just we are going to not look at it in the table. So those who support the tax, it's the bottom of that first column. That's 408 over 1068. Those that are male, that's the far right-hand side of the top row, which is 505 out of 1068. And then where that row and that column overlap is the minus 172 out of 1068, because those people would have been double counted. Those 172 individuals would have been counted under those who support the tax and those who are male. And so we have to always remove double counting. That's what this version of the addition rule is about. It's getting rid of double counting. So when we add and subtract, we end up with 741 out of 1068. And as a decimal, we get 0.6938202247, rounded to the nearest thousandth, is 0.694. For part C, this one's a little different. And you could totally do it the same way we've been doing, but there's an actual easier way to do this one. The probability that the person is not unsure or is female. So not unsure means that they either support or oppose, right? We have a column for unsure. Not unsure would be the other two columns combined. Well, when you think about this, the probability that they're not unsure or that they're female, the only people on this table that wouldn't be included would be those who are unsure and male. So that would be the only group not included. So the probability of being not unsure or female is the complement of being an unsure male. So we can do 1 minus the probability of being an unsure male, which is 1 minus the 10 over 1068. We need a common denominator, so we write the 1 as 1068 over 1068 minus 10 over 1068, which is 1058 over 1068, and as a decimal, 0.9906367041 rounded to the nearest thousandth is 0.991. And that's your answer.